So we got two more talks between now and the coffee break. Next up is Matthias Greiner from the Federal Institute of Risk Assessment and the University of Veterinary Medicine in Hanover in Germany. Floor is yours.
Thank you, Shaman. I'd like also to thank EFSA for putting together a really exciting conference. Dear colleagues, I'm not so sure whether exciting is really the right term when we talk about weighing evidence and assessing uncertainty in the microbiological risk assessment. But maybe after my talk, maybe we can agree that at least the challenges we have in front of us are exciting. So let's see what I'm planning to do. I would like to answer three simple questions: what, why, and how. What is evidence, uncertainty, and weight of evidence all about, and what are application areas in microbiological food safety? And then why? Why do we need to apply those concepts more systematically in the area of microbiological risk assessments? And then secondly, how can we use these concepts to deal with the limitations of our knowledge? Up front, I should give credit to the colleagues and members of the current working group of the EFSA Scientific Committee on guidance on the use of weight of evidence approach and scientific assessments. I think what I can present today is really inspired by the discussions in this group. And of course, on the other hand, all the shortcomings in my presentations are of course entirely my own. Okay, I will skip a few slides in the interest of time. Maybe I can also skip this slide. It just as a starting point tries to define some of these terms. I should say that the weight of evidence definition which is cited here is under current review in the working group. So maybe at the end of this work we will have a more descriptive definition. I had been interested to see in which contexts the statements about evidence and uncertainty is found in the area of microbiological risk assessments. And for this purpose I took the liberty to search in the EFSA extranet, which is a repository of documents of EFSA and collaborating partners. The search was not restricted to any publication date or any particular panel. And here you can see the search strings, search for evidence and uncertain, and then in combination with other terms that try to identify application areas in microbiology. The text snippets that came up with this search, rather than the full documents, have been used as a text corpus, and the analysis is based on only those sentences that use the word evidence or uncertain or uncertainty. So here's the result. EFSA documents that use the term evidence counted up to 166, whereas documents in which uncertainty has been used as a term were a bit fewer, 137. On the left-hand side you can see words or terms that occurred in phrases or sentences about evidence. And also I would try to skip to read through this in detail. It seems that the term evidence is used in EFSA text in combination with other terms that describe concepts like population. For example, we find humans or poultry, age groups. We find terms that reflect a certain etiology. We can see Campylobacter, I think we can see some toxin, botulinum, etc. And we may find some terms that are related to the endpoints, the health endpoints. We find something about infection and other morbidity, which reflects that the term evidence has been used in a kind of conclusive statement about a risk occurring in a population with regard to a defined endpoint. On the other hand, we see the uses of the word uncertainty, and here it seems that the phrases in which uncertainty has been described are more likely to be linked with specific input details that have been subjected to an assessment of uncertainty. So things like virulence, intake, strains, type, etc. May indicate that these concepts are related to specific input elements into a risk assessment in the area of microbiology. So in summary, with all caution, of course, this is a very limited analysis. It seems that statements about evidence are more likely to occur in conclusions, whereas statements about uncertainty are really referring to the scientific background of defined input elements into a risk assessment question. How does it compare to the use of these terms in the general science, I would say? So for this purpose, the same search has been repeated in Science Direct, which is a scientific content source and covers more than 2,000 journals. And the search here conducted was only restricted to the freely accessible contents. At the end, only the title, abstract, and keywords have been used. So the search is just an adaptation of the same search string as used for the EFSA texts. And here, the title, abstract, and keywords have been extracted. And again, the analysis have been restricted to only those sentences in which the word evidence or uncertainty occurred. Here are the results. First of all, we see, not surprisingly actually, more hits. There's 382 papers in which evidence has been used, 100 papers in which uncertainty has been used, and then even a few, only 3 papers in which both terms have been used. Okay. What could we learn from the pattern of words occurring in the same phrases along with evidence or uncertainty? If we look into the left-hand side, we see lots of words or terms that seem to be related to very specific research aspects. There's very few terms that are necessary to describe really a conclusion. In a conclusion, you would have a statement about a population, you would have a statement about the endpoint. Here you see lots of terms which seem to indicate that evidence is more discussed in relation to very specific research topics. On the right-hand side, looking to uncertainty occurrences, those terms are a little bit more familiar with the risk assessor because the terminology or the wording here covers risk, variability, uncertainty, estimates, assessments. So that, again, with all caution, reflects a language which is also the language in regulatory science and in the science of risk assessments. So again, with all caution, we could speculate that evidence in the general scientific literature is used as part of the discussion when each single research topic is discussed under the, let's say, perspective of evidence, whereas uncertainty seems to be a term which is somehow at least inspired by risk assessment methodology. And we should also point out that there are certain number of very frequent terms that indicate that the use of uncertainty is in relation to quantitative models. So we see lots of terms like models, Bayesian, even Monte Carlo, things like that, that indicate that uncertainty is a specific, in the scientific literature, very often used in relation to quantitative modeling. So this is, of course, a very limited and very vague statement. What we can look at very precisely is whether the term weight of evidence is used in the two different sources. In EFSA extranet, we find 7 hits in all areas combined, where the term weight of evidence or some other spelling variants of the same concepts have been used. It turns out that there's no result that describe these or use these terms in relation to microbiological food safety or risk assessments. It's different numbers, but still equal results. If we look into the science base, there's lots of papers that use the terminology weight of evidence, and in combination with the application in microbiological food safety, there's no results. What does it mean? Is that not used in microbiological risk assessment at all? Is it a concept which is foreign to this application area? Definitely not. We can start looking into the microbiological risk assessment series is issued by the WHO. And we will see lots of references to the weight of evidence concept. For example, in 2003, this approach has been used for causality inferences, and here also with reference to assessing quantity, quality, and nature of the results available from various study types. I think that is the important point. But also pathogen characteristics, biological mechanisms, and extrapolating from animal or from in vitro studies to humans. Then a little bit later in 2006, it was mentioned that weight can be proportional. Okay, I have to hurry up. WHO advocates the use of weight of evidence approach for integrating evidence. Here are some other findings where weight of evidence is used. I will cut this also short. I should say that that one specific application for risk ranking will be presented tomorrow in another section by Kostas Koutsoumaanis. Briefly, the justification, why do we need that? There's complexity in microbiological food safety. There's a traditional way of looking into the interrelation, which is the epidemiological triangle that combines factors referring to host, agent, and environment. And these are the classical aspects that we have to consider on the area of host, that should be host here, sorry, agent and environment. And now we have discovered that it is even a little bit more complicated. We can define a subset of bugs which are causing clinical signs, which is the infectome, which is part of a microbiome, which is part of the abiotic and biotic exposome. So that means that adds a lot of complexity. How can we deal with this complexity? It is good practice, whether we follow Codex Alimentarius or OIE scheme or framework for risk assessment, to deconstruct a complex problem into components and parts. And I also, in interest of time, will skip that. The purpose to do this is that we can also use these elements of a complex question to assess uncertainty with regard to the risk questions, uncertainty in regard of scenario model parameters, data, and even calculations and simulations. And there's a current draft guideline about uncertainty, which will be also presented by Annie Hart in this session. And also at BFR, we developed some guidelines which focus on the exposure assessment uncertainties. A final word about combining evidence. I think we have to differentiate two situations. If we are in a meta-analysis situation, then we deal with multiple primary studies of the same question with comparable outcome metrics like odds ratios of epi studies. We have to follow certain rules. We have to be systematic, and there's guidelines around how to be systematic. We use instruments to assess quality. We use inclusion, exclusion criteria, etc. But at the end, we have something like an evidence integration based on a statistical approach. This is quite different of the weight of evidence situation, because here we are dealing with primary studies with different type of observations, in vivo, in vitro, in silico, epidemiological studies. And the approach resembles a meta-analysis approach, but we do not have established guidelines how to combine the evidences. And this is done work that we need to do. And I cannot present you the final results, so to speak, but combining evidence would be about judging the evidence that we have of from different lines of evidence, from in vitro, in vivo, epidemiology, or other studies. We have to look into the validity aspects, relevance aspect, construct weights, look at the outcomes, and then try to summarize this picture. I think briefly I should mention that weight of evidence is used also in a different notion, more in the notion of grading the evidence. And I think the scheme proposed by Health Canada is one of the examples. For example, in the analysis of foodborne outbreak or foodborne illness outbreak results, it has been suggested to judge the plausibility of a certain vehicle to be the source, vehicle and source of the outbreak by considering different evidence situations. And here it is like being in a situation where you do not have access to all these multiple informations at the same time, but you can just see in which situation you are, and then you can judge whether there's strong or rather weak evidence for your conclusions about plausibility. And there's similar criteria for other aspects in outbreak investigation. Finally, I will skip again a few slides here and just go to this one here. There's another interesting application of weight of evidence when we talk about dose-response models in microbiology. The classical approach is to use biological reasoning about underlying assumptions, asymptotic behavior, and then choosing the model for dose response with the best fit or where the biological assumptions are met. The weight of evidence approach, which can be used here, has been proposed, is to use all models at the same time and combine the results mathematically. So here we are not looking at different lines of evidence like different data sources or studies. It can be exactly the same data points, and the differences are we have alternative mathematical models to explain the data, and it has been suggested to use a certain statistical criterion. Here's a Kalbeck information criterion to weigh the information and to summarize this. So it's a very specific application of weight of evidence in microbiology. So the conclusion, internal validity and relevance for the question can be part of an uncertainty assessment, but can also be used for deriving weights and evidence, weight of evidence approach. And the two methodologies, weighing of evidence and uncertainty assessments, should be thought to be complementary, and they have a common overall goal, which is to provide the best possible basis for science-based decision making. So this is, so to speak, the wrap-up or state of the art, more or less, in microbiology. And there are lots of experts around. If any of you have more recent applications of weight of evidence, which is maybe unpublished, please let us know, because it's current work and we would be interested to know. Thank you for your attention.
Thank you. Thank you very much.